Alright, in this video we're going to take a look at identifying linear equations, just kind of the basic idea here of doing that. So let's go ahead and look at some of the definitions and concepts that go behind a linear equation. So a linear equation is an equation whose graph is a line. So hopefully we can hear line in linear. So literally it's just going to be a graph of a line like this. When we're doing a coordinate grid, it's not going to have any kind of bend in it, meaning it's not going to be a parabola like this. Okay, or we do have other types of graphs also that kind of have curves in them. We have exponential graphs eventually that have this kind of soft curve on it. We don't want any of those. We want it to just be a nice straight line. So we have been using slope-intercept form of a line where y equals mx plus b. So this is where m is the slope of the line and y is the, b, I said that funny, b is the y-intercept. Intercept. So an intercept is where it crosses the line, so that's this b here in the equation, and then m is the slope. X and y would actually be a coordinate x, y, like that. And they're going to be real number constants. So if this doesn't look familiar to you, hopefully this is a quick little review on slope-intercept form. It is definitely a very common form that we use to graph a line and to pull information from. So an equation is not linear if its graph is not a line. So hopefully that makes sense. A linear graph needs to be a line. If it's not a line, it's not a linear equation. So equations in simplest form with the following characteristics are not linear. So if we find these things, then it's going to be a no, it's not linear. So we have a variable, don't know why that L is not going there, is raised to an exponent other than 1. So an example of this would be x squared. That does not work. X cubed. That does not work. X to the first power is actually just going to look like x. We don't write the 1 there. So all we want to see is x. No exponents, really. We also can discredit, or not discredit, that's kind of a funny way to say that it's not a linear equation if the variable appears in an exponent. So if we see something like 2 to the x power, this is exponential. We do not want this to happen. This would be a no. That's not linear. Okay, so these are really the two questions we just want to ask. Is there an exponent other than 1? And is there an exponent that's a variable? If I answer no to both those questions, then we have an equation that's linear. So if we look at this first one, my exponent is 1. I know that because I don't see it. So if you don't see a number there, it's 1. So this one is perfectly fine because I don't have any variables with exponents larger than 1. So this one I have a cube, so that does not work, so that's a no because 3 is bigger than 1, so I can't have that exponent larger than 1. If we go down to C, I have 1 and 1 again. I know that because I can't see them, so there's no exponent, which actually means it's a 1, so this would be a yes. This works perfectly fine. Now I have an exponent of 2, so that does not work again. That's too much. I can't have that exponent of 2. That changes it. This actually would have a shape like this with an exponent of 1. A cube is going to have another shape. We don't necessarily get into too many shapes, so I'm not going to go too far down that road. But this is the basic idea of identifying a linear equation. So go ahead and go on Alex and give that a try. I don't know why that zoomed out so far.